Welcome to this session, a single overview of CNC machine evolution. CNC is just computer microcontrol, where you're using a coded instruction to control machine table, machine tool, when it moves from one point to another to cut or produce parts, or to shape the desired parts through what we call subtractive or additive manufacturing. So in this case, just if you look at how this came into, we moved from conventional manual machines where we able to move the hand wheels or levers to create parts. These machines were not well automated, and then we moved to NC control. We call them numerical control. Previously, those machines, they use what we call punch tapes to create G codes, which were semi-automated. They were hard to modify. Some, even the setup was very complex. But when we come to now, from 1970s, the present, I think now when they developed what we call the microchips, they introduced now aspect of computer. Also, not the computer has purpose of reading, inputting, controlling, computing, giving an output, or storing information. So this is what is now gave us what we call the CNC machines due to the development of process of microchips. So this now created what we call integration of CAD/CAM, computer aided design, and computer aided manufacturing. And now we're able to see many 2-axis, 3-axis, 5-axis and above came into. This one now needed a very skilled programmer or operator to create these programs. When we come down to the 2000s and present, you may see how this now came into. Like now we are using smart CNC, which has Internet of Things, and is very predictive because they're using sensors to detect exact movement. Either you're using absolute smart system or measuring system, or using incremental measuring systems. Even it's able to predict when to be maintained. Let's say maybe checking the coolant or putting the hydraulic oil, all of this. Then now the future, which also emerging, is now using AI CNC. Now we have AI CAD/CAM systems. So this may be now what the world is moving towards, so that we're able to create autonomous systems which can adapt to the changes in the design and changes in manufacturing. When you look at these stages, conventional stage, conventional stage, as you can see how it came, like the control was so manual, automation was low, flexibility was low, and even the limitation was on operator dependency. So meaning the operator was to be so skilled such a way that they may reduce these errors. When we came to the stage of NC, that is numerical control, where the control was using the what we call punch tape, and then the automation was medium, that's semi-automated. There's aspect of low flexibility also, and then the key limitation here is it was hard to modify. Then we came to the stage of CNC now, CNC, where introduction of computers, this now created high automation and high flexibility, which now require the programming skill. That's why we train people to become programmers. We have the front-end programmer and the back-end programmers. So this is the front-end programmers, not the back-end programmers. And then we have the smart CNC. Smart CNC now we're able to connect system, because in this control we have sensors, we have advanced systems which can detect or maybe even humidity, temperature, heat, maybe moisture, maybe movements like absolute and incremental measuring systems. Then this aspect, automation is very high, even flexibility is very high. And then in terms of the key limitation is the data security challenges. Yeah, every advancement has its own limitation. Then now the future AI system, artificial intelligence systems, the control may be intelligent, yes. Automation may be autonomous, yes. Flexibility may be extremely high, but still it is evolving. we can also look at now the stages of mechatronics. Mechatronics is a mechanical engineering systems which has integrated machines, thermodynamics, electronics and controls, so that we call them mechatronics, which this one brings aspect of automation. When you put sensors, when you put actuators plus feedback, then it creates a mechatronic system. So this one has evolved. Like if you look at the industrial 2.0, I think mechanical engineering is industrial 1.0. Then we have industrial 2.0, where we have aspect of electrification or mass production. This was evolved between 1870 and 1914. Then we came to industrial 3.0, where now evolution of computers and also PLCs. PLCs are what we call programmable logic control. So where when they evolved these systems, now it created what we call industrial or industry 3.0 between 1970 and 2000. And then now from 2000 and beyond, we have what we call Internet of Things and artificial intelligence. So this is a smart factory where you're using even robots to automate your systems. So this is what we call industry 4.0. Now there's one which is upcoming. Maybe the future will be called industry 5.0, because here there is aspect of now human AI robots, which is now the future industry 5.0. So to summarize, mechanical systems, mechatronic systems, when you put them together, you create industry 3.0. Then from industry 3.0, it will advance to industry 4.0 and beyond. So this is a simplified overview of CNC evolution and mechatronics evolution.